Welcome to Steel Talks, a podcast by ArcelorMittal, hosted by applied futurist Tom Cheesewright. In the first of a four-part series, looking at the role innovation plays in ArcelorMittal's success, Tom talks to Jean-Luc Thirion, our Global Head of Research and Development, about our approach to R&D and the emphasis we place on product development.
Jean-Luc, steel is obviously a long-established industry. What's the value of investing in research and development, given that long history and how sort of well understood the sort of production process is?
I think that our industry has always been subject to enormous pressure from the competition from other steel makers who do not always play by the same rules as us, by the way, but also competition from other materials. And I think that innovation in products, in process, in our methodologies is exactly what creates differentiation and allows us to stand out. And of course, innovation is driven by global R&D in our company in conjunction with industrial and commercial entities. And I think that our strength is to offer the products that the markets expect, always the first on the market or among the first. And our strength is to, I would say, combine these products development with process and digital development to optimize our reliability, the quality of our products, our cost, our carbon footprint. And this is where we are differentiating, in fact.
You mentioned carbon footprint there. I guess in many ways, one of the most recent pressures to be applied to the industry is around the control of its emissions, all of its different emissions, both carbon, pollution, etc. Has that been a more recent driver for R&D?
Not so recent, in fact, because, for instance, carbon footprint, it was one of the main drivers in automotive industry with reduction of CO2 emissions, reduction of fuel consumptions. And in the two last decades, we developed a lot of solutions already to work on that. But you are perfectly right. Now, there is a move to decarbonization. It is important to decarbonize, first of all, the activities of our customers. Again, with the example of automotive, they are decarbonizing their activities by going in the direction of electrifications of vehicles. But what is clear is that when the vehicles are electrified, the main CO2 emissions becomes the CO2 emissions from the steel makers. And that's why, to stay on the market, we have to decarbonize. And you are perfectly right. This is a very significant activities from global R&D and from our colleagues from operations in order to develop technologies, processes to decarbonize the steel processing, the steel manufacturing, but also to learn how we can completely redesign all our products, because working on new processes like electric arc furnaces means that we have to redesign all our processes, and we have also to ensure our freedom to operate, because when you redesign, that means that potentially you invent new chemistries, you invent new processes, and it is very important to file patents in order to protect our freedom to operate. So you're perfectly right. It's a major target of the company, a major target from R&D.
A big driver. And so given those different pressures, you've got the competitive pressure, you've got the sort of the environmental pressure. And actually, you've got that sort of pressure to respond to a changing world. You talked about, electrification. That's got to drive quite a significant organization if you're trying to respond to all of those challenges. Just give us a sense of the scale of the R&D effort at ArcelorMittal.
In R&D, we are 1,700 researchers today. We spent around $330 million every year for research. So it's a very big effort to support the commercial, the industrial strategy of the group, and again to stand out and be different from the competition. So it's indeed a big effort, and I believe that we do that in several countries, several continents. We are present in Europe, we are present in USA, in Canada, in Brazil. We have an antenna also in Japan, for instance. So we are present where we have good contacts, internal contacts in our plants or by our customers, of course. And this is the way we work. We try to develop many things, but also to be locally present, to roll out our solutions, and to ensure the dialogue with our internal customers, but also with our external customers.
You talked a bit before about some of the pressures in the automotive industry driving change and innovation. I'd like to dig into that a little bit more, because obviously it's an industry that's gone through dramatic change recently. We all recognise that electrification has been an enormous shift, but actually it's a long process of change for that industry, responding to safety standards, responding to sort of cost imperatives. Can you talk a bit about how the R&D function has responded to those different drivers over time?
Yes, with regard to the automobile industry, ArcelorMittal has played a major role in the last 25 years in maintaining steels as the material of choice. At many moments, the automotive industry could have moved to aluminum, for instance. We have achieved this through product process innovation by developing multiple very high strength steels, because indeed the main drivers was safety, was weight saving, and the key technical answer for that is advanced high strength steel. So we have developed multiple products. We were pioneer in a number of families of product. And just to give you an example, in 25 years, we have multiplied the strengths, typical strengths of steels by 6. We were around 300 MPa in beginning of 1990. And we are now more than 2,000 MPa in the product that we propose.
And that's megapascals.
Megapascal, yes. And thanks to these products, we have typically reduced the typical weight of a vehicle by 25%.
It's really interesting. I don't think there is an understanding in the world at large. And I speak to a lot of car people. I do a lot of work in the car industry. But the general public doesn't understand that steel isn't steel. Just how much even the raw technology of the framework of the car has changed over that period.
Yes, that's true. Every steels are gray, but this is all what is common. And there are multiple properties, of course. And these properties are the strengths that have an impact on the ability, for instance, to absorb crash for a vehicle. But the mechanical properties have also an impact on the way to weld a steel grade, on the way to stamp, to form a steel grade, and so on. And we have always tried to develop product in order to optimize, to find trade-off between all these properties, which are very often in contradiction. And I think that what is important to mention in our success, beyond the development of product, is the methodology. We have developed, for instance, in 2010, a concept which is called S in Motion. It was the first S in Motion project. And meanwhile, we developed a lot of other S in Motion projects. And the objective was to make engineering in order to showcase all the benefits of our new products to the customers. We wanted to show them how our products could be used in an optimal way, how we could indeed weld, stamp, and so on, how we could develop some innovative design to take benefit of all these properties. And also, we develop an outstanding knowledge in terms of steel processing, in terms of knowledge regarding the way to use steel in an optimal way, and in terms of properties for crash, for corrosions, for fatigue, and so on, all the properties which are important for automotive. And thanks to this method, we became, I think, a major actor in this world. And the best solutions that we propose today to the market comes also from this expertise that we developed year after years in this company working with our customers.
And so, what does that look like now? If an automotive manufacturer comes to you now and says, what's the latest, what's the greatest, what's R&D come up with that's going to change my world as a manufacturer, what are the solutions you're taking to them?
Yeah, see, during these 25 years, which I mentioned, the main driver was safety and weight. And today, the main driver is, first of all, electrification. So it has a direct impact on the way cars are designed. For instance, you have a battery pack in a battery electric vehicle. And that means that you change completely the distribution of mass in a vehicle. And we have to work on the consequences and find and propose the appropriate products to answer to these new needs. But I think that something very important is the concept of simplification and cost. The problem of electric vehicles is that they are expensive. And Tesla especially changed a little bit the paradigm by proposing new methodologies. And they changed the paradigm and they pushed all the market to try to simplify the way we manufacture cars and to try to optimize the cost of manufacturing. So we had to answer this challenge. And thanks to our expertise on product for hot stamping, our expertise also on laser welded blanks that we developed 15 years ago, we proposed gradually some concept like, for instance, dooring. And dooring is a major commercial success. And dooring is only the first example of a more general concept, which is called MPI, ArcelorMittal Multipart integration. And the objective is to reduce the number of parts for the car makers, reduce the number of welding robots, reduce the size of the shop floor, and so on. So we are creating an enormous value with this concept that is being rolled out for the time being in each and every continent, and which is quite successful.
So let's explain that concept in a bit more detail, because 30 years ago I visited a car plant, and you've got lots of robots spot welding small stamped pieces of metal together to make the frame of a car. But with MPI, you're rather changing that, aren't you? You're giving them a much sort of simpler single piece, or a small number of single pieces to put together.
Yeah. Yes, exactly. And for instance, for the just to give you an example, with what we call the H-frame. H-frame is the rear module of a vehicle. This is a part which has an H shape, and usually this part is made of up to 13 parts, spot welded together. So that means that you have welding robots. That means that you have intermediate stocks and so on. And with our concept, we replace the 13 parts by one single part. We deliver a dedicated specific blank to the car makers, and they stamp this blank, and they get an H-frame without welding robots and with a very clear reduction in terms of weight, very clear reduction in terms of surface of the shop floor, reduction in manpower. So this is really something very important to keep producing affordable vehicles, because one of the major challenge from many car makers today is to be sure that the cost of vehicle remains acceptable for the market.
So MPI is one of the sort of the big hits, the sort of greatest hits, if you like, of R&D. But there's a number of different products that have a variety of different properties that have come out of ArcelorMittal over the years that stand out in different sectors. I wonder if we could talk about a few of those. We've talked about Magnelis a lot in the past on the podcast, but I know there are some others that have particular properties that appeal in different parts of the market.
Yeah. Yes, indeed, automotive has been and is still a very important market, but automotive, we see today that it's a weak market also, and for sure, ArcelorMittal could not rely only on automotive, and years after years, gradually we develop an excellent expertise also in the so-called industry market, which combines a lot of objectives. Industry market includes construction market, includes all what is related to energy transition, all what is related to metal processing, to packaging, and so on. So we have developed a very good expertise. You mentioned Magnelis. Obviously, it's a big symbol, because Magnelis, like Usibor for automotive, has been a very successful product, very successful, especially for global energy transition. This is one of the major products which is used for renewables energy, especially for solar applications. But indeed, there are also other key products. You mentioned Optigal. Optigal is also a zinc magnesium coatings, which contributes a lot to optimize the cost of the pre-painted products which are used in construction market. So thanks to Optigal and their very good properties in terms of corrosion, we reduce the cost of the product, and we optimize the use of this product for construction. You mentioned also Armstrong. This is a very big family. Armstrong is a family dedicated to the advanced high-strength steels for industry, which are hot rolled. So this is a rather thick product, which are dedicated to mainly two markets. The market of yellow goods and green goods. Yellow goods is the market of construction equipment, construction machinery, and green goods is the market of agricultural application. So Armstrongs are advanced high-strength steels a little bit similar to the advanced high-strength steel for automotive. They are bringing weight saving. They are bringing improved performance in terms of fatigue, in terms of durability, in terms of wear resistance. For instance, for tippers, you need to optimize the wear resistance. And this is typically what this product brings. And the market is quite enthusiastic, I would say, with this product, because exactly like for automotive, probably 15 years ago, we were below 500 megapascal in terms of strength, and today we are developing product beyond 1100 megapascal. So it shows the same trend as for automotive for another market, and I think that this is something very important.
That must be quite a visible change in the construction of farm equipment or construction equipment, a digger or a crane or a tipper, as you say. If you're using a steel twice as strong, you must be able to see that in the construction of the vehicle.
Yes, sure, and especially it's also a matter of cost and a matter of sustainability. Why? Because with higher strength, with very high strength, you are able to reduce the thickness of the material. First of all, you reduce the cost, of course, and that means that in terms of competition, it's a good point. But that means also that you use less material. And for sustainability, for decarbonization, it's a way also to decarbonize. Using less material is a way to decarbonize. And this is something on which we are highlighting a lot what R&D brings. Because on the one hand, to decarbonize, we are developing products with low CO2 emission. Under the brand name XCarbRP, we are producing product in all these markets which are produced on lines which have low carbon emission. This is the first way to decarbonize. But another way is to optimize the use of the material, optimize the thickness of the material in order to reduce the amount of material that we are using to manufacture an equipment. And I think that we are completely meeting the trend, the important trend of decarbonization, which is today very, very significant in the world.
Very much so. Jean-Luc, when you're tackling a challenge like evolving a product like Armstrong, what does that process look like? Does it start with a conversation with the customer? How does that evolution come about?
Yes, this is one of the inputs. In fact, when we develop a new product, we have two kinds of product. We have pull product requested directly by customer, by the market, and push products where we have the idea that it will create value for the customer. So we manage both type of product, and indeed sometimes we combine the information from the market and what we can develop in-house in terms of innovative process, innovative product. So we have an idea. We define a technical target. We work very early with commercial people in order to identify the size of the market, the potential profitability, and so on. And when we find an agreement that there is a potential, we accelerate the product development in-house, in R&D. And when we are ready, we go to a first industrial trials. And generally, it requires a number of industrial trials in order to be sure that you have a robust product, robust chemistry, and so on. Basically, the time to market for a new product is 3 years. All this requires 3 years between the first ideas and the first commercialization.
This is a big question because we're talking about a large organization with a lot of people and a lot of different locations looking at different challenges. But if you could pick out some of the highlights in terms of where R&D is focused today, so what are the challenges that you're trying to solve, and where you see sort of products coming down the pipeline, what excites you about most what's coming through the pipeline of R&D today?
We are working on 6 main areas, 6 main strategic areas. Obviously, to be consistent with what we discuss, we want to keep on developing sustainable products, to keep on differentiating. Especially, we have a focus on mobility. I don't speak today only of automotive. We are speaking of mobility because the concept of mobility is evolving with, for instance, the concept of micro-mobility. So micro-mobility is probably one important market of tomorrow. The other domains, the other 4 domains where we are working a lot are clean energy transition. There is clearly an energy transition in the world. This has an impact on our processes, but it has an impact on the processes of our customers, and obviously it has consequences on the needs for new product. What is important and what is key is also environmental excellence. We are working, for instance, on specific processes, specific methodology to control our dust emissions, and we want absolutely to comply with the regulations in terms of environment. And as we discussed, decarbonization is one key objectives. So it has an impact on our product, on our processes. And the last one, which is everywhere, this is artificial intelligence. Artificial intelligence is everywhere. We have developed in the last 10 years a very strong expertise in this domain. We are applying this domain in multiple operations within the group, for instance, in predictive maintenance, but also in business optimization. And we are using more and more artificial intelligence within R&D to optimize the methodology that we apply to develop new products or new processes. So artificial intelligence is also everywhere. This is the key strategic objectives of global R&D today.
Brilliant. Thank you, Jean-Luc.
We hope you enjoyed listening to that as much as we enjoyed producing it. Tune in again next week when Tom will be talking to Carlos Alba about how we are harnessing artificial intelligence across our group.